Is interested in taking final exam 1 week earlier, and I have one request already. So if anyone else is interested, let me know.
Sure. Oh yeah.
Okay. Wide area networking. All right, let's watch this video first, which is about configuring. Let's first watch this video, creating VM instances in AWS. Okay. How to create a virtual machine in Amazon Web Services cloud environment.
Hi y'all, I'm Jill West, author of the CompTIA Network Plus course from Cengage. In this video, we'll be working through the project, Create a Cloud VM Instance in AWS. Now, we've already created VMs in VirtualBox. An EC2 instance in AWS is much the same idea. And in this project, we'll find what kinds of options we have available as we design that EC2 instance. So let's get started. If you're using a standard AWS account, one that you created on your own without any connection to your school, you will sign in directly at aws.amazon.com, choose root user, then enter your email address, click next. After that, it will ask for your password. If you have 2FA set up, then it will need information for that as well. If you're using AWS Academy as a student, you'll sign into your AWS Academy site. This is the dashboard page. Click on your Learner Lab course, whatever that looks like for you. It's going to look a little bit different than this, but similar tile shape there. And then click Modules over here on the left. Scroll down to this Launch AWS Academy Learner Lab and click this link. Once the page fully loads, you'll be able to click Start Lab over here. And this takes a couple of minutes because it's generating various resources and other things that it will need access to within your AWS environment. So wait for the spinning arrow here to stop. This button should turn to a green color. Once it turns green, then you can click the AWS button here, and it will take you to the AWS Management Console, just like the people who have the standard AWS account and are signing in here. So I have a green button here now. I'll click AWS. And here is my AWS Management Console. So everyone should be able to get to this point, whether you're using a standard AWS account or if you're using the AWS Academy account. This is what we need to get to before continuing with the project. So from here, we need to go to the EC2 service. I have it listed here in my recently visited. If it's not here for you, you can click in the search box up here at the top, type EC2, and it should come up as the top option on the list here. So click EC2. This takes you to the EC2 dashboard. You can see that throughout these options, you should have zeros for most of this. You might have one key pair sitting here and maybe a few security groups, whether you've done anything in this account yet or not. We're going to launch an instance, which is essentially a VM, a virtual machine in AWS. So click Launch Instance. First, you need to give your instance a name. This could be something simple, so you could put my-EC2 or use a different name here, whatever makes sense to you. Just keep it clean. Now, most of the default selections that AWS has set up here is correct for this project that we're doing here.
So they provide you what type of EC2 you want to have. Different operating system options are available, like Amazon Linux, Mac OS, Ubuntu, Windows, Red Hat, SUSE. So most of them are Linux, but only one Mac OS and one Windows. So you can create any of these type of virtual machine on AWS. And it's not just AWS, it's on Google as well as on Microsoft. Similar kind of options you will see in other cloud platforms as well.
But let's check these options and talk about them a little bit so you understand what they mean. The first option is to choose this AMI, or Amazon Machine Image, and this will determine what the operating system is for your VM. By default, it's selected Amazon Linux, but you can see there are a lot of other options here. You could do a Mac OS system, Ubuntu, Microsoft Windows, Red Hat, SUSE Linux, and several others. There's Debian. You could
So these all are pre-created machine images, and using these images you can make your own copy, right?
also click this link here for browse more AMIs, and you can see a whole lot of AMI options through here. You can see the quick starts, there's 45 of them. AWS Marketplace offers almost 10,000 AMIs, and it might be more than that by the time you're doing this project. And then community AMIs. Just be careful if you decide to use these community AMIs for anything. These can be published by anyone, and they may or may not be trustworthy. So typically you would want to get the
So AMI is like machine image, and you can also create your own AMI and publish it on Amazon or other cloud platform. So what the AMI does is are the prefabricated virtual machine for certain operations, such as, let's say you would like to create a virtual machine image for computer investigation, for as a computer forensic investigation you are creating that, or you want to create a virtual machine image to track the network traffic. There might be those images already created. I'm just giving you an example, an idea. So you can create your own virtual machine image using this platform, and you can either use it for yourself, just keep it for yourself, you don't want to publish to others, or you can put it on AWS Marketplace so that other users can use it. So AWS Marketplace, most of the time, those are paid versions of machine images. Community AMIs are mostly free versions. Community AMI, like someone has created and they want to let others test those images, So you can publish them on community AMI. But those are not reliable images. They may have some kind of problems in those images. So, or you may not get any support. So AMI, community AMI, like you do not get any support, or if you get, then you may need to wait for a few days. Marketplace AMIs, where these are published by various companies or vendors, but you can get the support as well. If they are on subscription, then you have to pay the subscription fee as well.
Either from the AWS Marketplace, from one of these quick start AMIs, or something that you've created for yourself. You can create your own AMIs as well. The AMI, as I said, determines the operating system that will be installed on your EC2 instance. So this is Amazon Linux and lots of other options, Mac OS, Red Hat, SUSE Linux, Ubuntu Server, Microsoft Windows Server, and lots of other options. We're sticking with this Amazon Linux. One thing I will point out, if you're using a standard AWS account, make sure that the options you select as often as possible are these free tier eligible options. That's one of the things I really like about AWS is that they tell you what options qualify for their free tier, so you don't accidentally choose something that is not free tier when you thought that it was. So I'll click select. It's just going back to the default that I had selected before, which should be the same as yours. And go back to my quick start tab here. So this should look just like yours now. The next option you need to make is your instance type, and this determines how much resources are available to the instance. For example, how much CPU power is there, how much memory is available to it, what about networking, storage, things like that. By default, you have...
So here you can select what type of resource you would like to allocate to your virtual machine. Okay? So memory, CPU, disk space, and all.
Of the T2.micro instance types.
Some of these are already created, prefabricated, and named as like T2 micro. So if you select T2 micro, you will see some number of CPUs, some amount of memory is already allocated to that virtual machine. Similarly, other types of other names are given in this list.
Selected. But you can see there are a lot of other instance types available. Here's the T2.micro in context with the others. It has one virtual CPU, which is essentially one core on a CPU, and then it has 1 gigabyte of memory that's available to it. Low to moderate network performance. You can scroll through this list and see how much bigger you could get with these different options for instance types. So here's one, it's called C5.Mittal, has 96 virtual CPUs, has 192 gigabytes of memory available to it, 25 gigabit network connection, and that's not even the biggest. You can see this goes on for pages and pages. So I would challenge you to take a minute here and scroll through some of these other pages, see maybe what's the largest instance type that you could find with the most amount of vCPU or memory or network performance available to it. You can get a lot larger than this. Of course, we want to stay on the free end, so we're sticking with
Only some of these models or some of these templates are free. Most of them are on paid. Okay, so don't go for the paid one. Is if you want to try this, you can try it, because some amount, or Amazon actually gives some credit. I think $200 of worth of credit. You can't take it as a cash, but only you can use that amount for these resources. So Amazon gives some credit to every new account. And if you are a student, like, you can use your GTC email ID, so you will get that free credit, and you can use those credits in order to create these type of resources. If they are having any kind of subscription fee, then you can use those credits. But remember that those credits goes very fast. You have to learn whether those credits are, or the cost of that particular subscription is per second or per minute basis. Whenever you are selecting a resource, and if there is a cost associated to that resource, then take a look very carefully if the cost is per second or per minute. Okay? Otherwise you will end up paying from your pocket, because you have to put the credit card or debit card information while you are creating this account.
I will cancel out of that selection to stay the T2.micro. Now, normally when you're creating one of these instances, you would want to set up a key pair. The key pair, if you're using a Linux system, the key pair is used to actually sign into the Linux system, kind of like a username and a password. If you're using a Windows system, the key pair is used to decrypt the Windows password that's assigned to that system so that you can turn around and sign into it. For this project, we actually do not need a key pair. We'll be using a built-in connect option, so we do not need a key pair. You can leave this at proceed without a key pair, even though it says that this is not recommended. Next option, we need to decide what kinds of traffic we'll allow through the security group, which is kind of a firewall type resource that helps control the traffic into and out of your instance. Because this is a Linux instance, we need to use Secure Shell to remote into it. So we will be allowing Secure Shell traffic, and we need to leave this at anywhere so that traffic could come from whatever your public IP address is. To be a little bit more secure, you would actually change this to a specific IP address and then put in whatever your public IP address is. So if you're at home and you're using a home network, you would need to determine what public IP address did your ISP assign to you. If you're working in a school lab, you would need to determine what public IP address is your...
Did you try to find your public IP address at home? Not yet?
lab computer using. So there's some public IP address somewhere that is being used to represent you on the internet. You would need to determine what that IP address is and then provide it here. And then the security group would lock this down so that only SSH traffic from that public IP address could enter the instance. And that would be more secure. If you're going to set this up for a production environment, you would definitely want to provide that level of security, or even better. But for a lab project where this instance will only exist for a few minutes while you're experimenting with it, and then it's going to go away, we're going to make this easy. So we'll leave this at the anywhere option for allowing secure shell traffic through. Next, we need to decide how much storage space should this instance have. By default, it has 8 gigabytes for its storage volume. This will be the root volume, and it's not encrypted by default. Here you could add additional virtual storage volumes if you needed more storage space. One of the neat things about the cloud is that you can store data in other types of storage, not necessarily in virtual hard drives or virtual SSDs. So you could store data like in S3, simple storage service. You could store data in a file system, a virtual file system that lots of instances could connect to. In this case, we just need this one root volume that's pretty small, just to hold the OS so that we can run the system. Okay, that's it for this instance. We'll click Launch Instance. This is a real VM, a real virtual machine, so it needs a minute or two to install its operating system. Now this is Linux, so it won't take very long, but it does take a minute or two. So let's scroll down here, click View All Instances. You might not see the instance in the list right away. If not, click the Refresh Instances button up here, and then you should see your instance listed here. For me, it's been long enough that this is in a running state. If yours is not yet in a running state, wait another minute or two, refresh every so often, and don't move forward until it's listed as running. Even before it's fully running, you can select the instance over here in the list, and this pane down here below will show you a lot of information about the instance. So you can see its instance ID. This is the information that you would use to identify this instance throughout AWS. So if you needed to connect it to a database or a Lambda function or something like that, then you would use this instance ID in order to identify this virtual resource in AWS. It already has a public IPv4 address. It has its own private IPv4 address within its subnet.
So now you notice that the virtual machine has its own public IPv4 address. Now using this public IPv4 address, you can do RDP, remote desktop, or remote login to this virtual machine. If it is a Linux or Windows, whatever is that, they support RDP. So using this IP address, either you can do SSH or you can do RDP.
Inside the VPC, the virtual private cloud, and you can scroll down here and find other information about it as well. With the instance selected here in the list, we next want to try to connect to this instance. So click the connect button up here at the top. Now we have a few options here for connecting to the instance. You could use Session Manager, which takes advantage of resources that are built into the instance. We're not doing that. You could use Secure Shell Client, which is a more traditional way of connecting to this instance. You could use EC2 Serial Console. We're not using any of these. We're using the built-in and easy to use tool, EC2 Instance Connect. So make sure you've selected this option over here on the left. This way you won't need a key pair, you won't need a password. It automatically assumes the username. We'll click connect down here. So this takes just a minute to establish the connection.
It's Linux loaded and you are connected. You can actually, you are viewing this inside the AWS window. You are not connected outside the AWS window. But if you would like to connect outside the AWS window, then you have to use that public IP address and some kind of remote connection tool such as SSH or RDP.
But now you can see here's the command prompt, and we are connected to this EC2 instance that's running Amazon Linux. So this instance, this virtual machine, is being hosted in the AWS cloud, and we're now signed into it to where we can interact with it just like we would with a virtual machine running on our own local computer. Let's interact with this instance a little bit. So we'll enter the command IP space ADDR for IP address. And what information does it report to us? Here's our interface that's assigned the IP address inside the subnet, inside the VPC. This is 172.31.93.26. I wonder if that matches what's over here for this instance. Go back to the Instances tab. What was its private IP address? 172.31.93.26. So you can see we have the same information from within the instance. Now you can choose a few Linux commands to practice using in this particular Linux distribution. We're going to skip ahead to the part where we create a directory. So let's enter the command make directory called my directory. A rush. Just as a reminder, if you're using a standard AWS account and you're still within your free trial period, this should not be costing you actual money. It's just eating up some of your free trial credits.
Listen, you are basically consuming some free trial credits. So I won't mind using it until I have some free credits available, because that will give you a brief experience with some cloud interface. And believe me, everything is guided. You can watch this video, you can take this video as a reference and do this activity at home or anywhere, and that will give you an idea. Now, if you ever get a chance to use AWS or Microsoft Azure or Google's cloud, you will notice that their interface is not exactly same, but very close. Very close. You won't feel that you are using something very new today. You won't feel that. Is if you are using Microsoft's cloud or Google's cloud interface, you will find it. Oh yeah, it has the same thing. It's something like you are reading a translated book in a maybe if you first you read it in English, now you are reading in Spanish. Something like that. If you know both the languages.
And same thing for those of you using AWS to carry up storage space in AWS's data center, so they continue to charge for the storage space, even the...
This is one video. And let's look at this video. Configure. There must be some other videos in different lessons. I would suggest, for example, this is the VLANs video, we got it already. This one is about configure cloud security in AWS. Means the VPC you have created, you want to secure that VPC, so you can get that idea. Just watch for a few minutes and then we will continue with our lesson.
Hi y'all, I'm Jill West, author of The Instance and Connect to It. So here on the EC2 dashboard, scroll down a bit, let's click this Launch Instance button. Give the instance a name, so I'm going with
Something
Project
similar.
92. And next we need to make sure that, so let's click Edit over here on the right. The default VPC is fine. We don't need a preference without a key pair, even though it's not recommended, we're just not going to need it. Next, we want to poke around with the network settings a bit. So let's click Edit over here on the right. The default VPC is fine. We don't need a preference on the subnet, and make sure that auto-assign public IP is enabled.
Remember one thing, that every time you create AWS environment, it always has its own default.
And make sure
default VPC is always created. VPC is your virtual private cloud. Means you have your own cloud environment in which you can create any number of virtual machines, any number of other resources like database instances, etc. And those all will operate under one VPC. So it will have the same class of IP address or same series of IP address on all those instances you are running in that VPC.
That auto-assign public IP is enabled. We will be creating a new security group, which the default name is Launch Wizard followed by a number. And by default, there's one security group rule here already. It will allow secure shell traffic over port 22 from any IP address. What other types do we have to choose from here? There's actually quite a long list. So you can see we could do all TCP, all UDP. We can do ICMP traffic, which we'll be adding here in a few minutes. SMTP, DNS, HTTP, email traffic from POP3, IMAP, and plenty of other options in this list. So scroll through and see which of these that you recognize. As far as source, you can see that we could also do from a custom IP address or from your own IP address. So when we click the My IP selection,
in this video, it is she's trying to create a security group where you allow or deny request on certain type of ports from a particular IP address. Either you allow or you deny. So you can watch that video later. Let's continue with the lesson PowerPoint. Wide area network or networking. So whenever you have a small network and you would like to connect to a larger network, you can use these technologies of wide area network or networking. So in this chapter we are going to compare the WAN connectivity technologies available, explain how routers manage inter-network communications, describe ways to secure WAN connections, and troubleshoot some common connection problems. So I'm sure if I ask you what is wide area network, so which network comes to your mind as an example? The whole internet. The whole internet is your wide area network, okay? And but it can be anything else. Like you have a company has network in this state, in this country. Just a company has the network or owns the network for its own personal or private communication. So that can also be categorized as wide area network. But otherwise, internet is the best example of wide area network. So these are not all businesses need the same kind of WANs. Now can I use internet to have my private wide area network? Can I use internet to have or to establish my personal wide area network? If yes, then how? or if no, then there is no how or why required, or why, yeah, if no, then why. My question is, can I use internet to have my personal wide area network?
Isn't a wide area network not personal? Isn't that-
Wide area network, not personal means belongs to a company, you can say. That's what personal I'm considering here, belongs to a company.
Oh, you need a password. Protect yourself.
Okay, you need a password to protect yourself, yeah. I'm
Because you
I'm
can have
not
it-
going up to that level, right? Before that, I need to know if I can use or not.
It would have to be virtual, right?
Yes, it has to be virtual. Definitely it has to be virtual, because internet is not which we can see from our eyes. Right? Can we see internet? Okay, here's the internet. But can we use internet? Yes, we are using internet everywhere all the time. So internet is all virtual, it exists, but virtually. The question is, can I use internet to establish my own private wide area network?
Yeah.
Huh? Anyone? Yes or no?
Yeah.
Alright, try to find out the answer, okay? No worries. WAN versus LANs. So there, that's what I keep asking to you guys, that you should have questions in your mind and try to find the answer of those questions. That's the best way of learning. And now we have lot of resources available at our disposal to get the answer of those questions. Someone is very tired today in the class. I don't want to name someone, but the person is very tired. Okay, the following are the characteristics of WANs versus LANs. Right, the comparison, the difference between a WAN and a LAN. Then WAN connection service options, broadband, the dedicated internet access. So broadband is the cable and bandwidth are shared between multiple customers. Can you give an example of this? Cable and bandwidth are shared between multiple customers.
The neighborhood thing.
Neighborhood, right? So you have Xfinity in your neighborhood. So Xfinity has one cable coming into your neighborhood. From there, they are going to split. They are going to split the connection to all the houses asking for internet connection from Xfinity. In this case, bandwidth is asymmetrical, which means download speed are faster than upload speeds, and they may not be same all the time during the day. DIA, or dedicated internet access. The bandwidth is dedicated to a single customer. So I would say the large scale, large size customers, they are the customers which are having critical operations. They can have dedicated internet access. So in that case, a dedicated bandwidth will be allocated, a dedicated line will be laid down for that customer only. Then DSL, digital subscriber line, is a WAN connection method that operates over public switch telephone network. We are not using this anymore, or maybe someone is still using it if the person is from old school. So this is kind of dial-up modem, DSL, digital subscriber line, where you use a phone line to connect to the internet. Right? Or some service providers are using their phone lines doubled up as their internet line as well. AT&T is doing, I believe they are still doing it. They are using their phone lines with the, and they tripled it. Their AT&T is using the same line for the TV, for internet, and for phone. The same cable they are using for all three operations. For their TV, for their phone, for their internet. Then cable broadband. So these all are the various examples of WAN connections. Now, fiber to the curb or fiber to the home. So they bring the fiber to the curb near your home, and from the curb to your home they may use copper cable. In some cases, they are bringing the fiber directly to your home. Earlier, I was having this connection fiber to the home from AT&T, but now I'm using T-Mobile wireless internet. Leased lines provide a dedicated bandwidth on fiber optic connections. So this is, if you are using dedicated, then how they are going to lay the line. This is an example or diagram. MPLS, or the multi-protocol label switching, which enables the multiple layers of types of layer 3 protocols. This is basically how this internet is going to be provided to various networks or various homes in the same cable. Cohesive WAN management for multiple connection types. So there may be multiple connections, but all of them or all the connections are running on the same cable. So that's your then cloud connectivity. Now, do I need a special connection for the cloud? No, I can use the same internet for the cloud connectivity also. But the only thing is, I can use their service through their portal only. So in order to access the cloud, they can use internet. But in certain cases, these cloud service providers are providing direct connection to the industry or to the company who's their client for the cloud services. That way, they can get the better performance of their resources, and there would be no security concern because they have a direct connection to their cloud resources. VPN is another example or another way of doing cloud connections, but again, VPN goes through the internet. VPN does not go directly, or there is no dedicated lines we have for VPN. The only thing is, it is a secured way of doing connections to a private network. Remember, VPN stands for virtual private network, means it is a secure way of using public network to connect to private networks, or to connect a private network, you can say. Using public network to connect to a private network. That's your VPN. Now you have software defined WAN or SD-WAN. So it relies on abstracted centralized. So basically, when you are talking about cloud, so you know that cloud has a network, but there is no physical device exist in the cloud to create that network. So all those types of networks are mainly software defined, or a network which is created by a software. Look at the packet tracer. Packet tracer is an application where you can work on switches, routers, and interfaces. But everything is created with the help of software application only. Same as in these software defined networks, you have everything in real, but not physical device. There is no physical device exists. Everything is created with the help of some kind of software application. So that's your software defined network, where you see yourself connected to the network, but no physical device involved. Then wireless WAN. So like a city-wide wireless network, maybe your cellular network. So you can roam around the country. You can go around the country using your phone or keeping your phone, same phone. You don't need to change your phone number. You don't need to connect to a different service provider now. There was a time, long ago, there was a time when we used to go to other part of the country, then we are kind of considered as roaming. We are in roaming because we are out of our state network. So we are roaming, and we may need to connect to some other, like here I'm using T-Mobile service, but the state I'm visiting has no T-Mobile. So there it may connect to AT&T or Verizon or something similar. So, but now we can roam around the country, even we can go to the different part of the world. T-Mobile supports, I think, 200 different countries, not 200, maybe too much. But it supports so many countries. You can go and use the same phone. You don't need to connect any other, but you will be considered as roaming. you will be in international roaming. So these are the various cellular networks we have. These days we are using 5G in most of the countries, but some countries are still, or some areas are still using 4G network. These 4G and 5G basically has a difference of bandwidth. Okay, the bandwidth difference and the type of data they can carry over that network. You can also use satellite internet services. Any example of satellite internet services these days? Starlink. Starlink. Yeah, Dish is I don't think so. They are providing internet services through their Dish service, but obviously yes, TV is all the TV services are. If you are using a dish antenna for TV services, then definitely it is a satellite service. Okay, and this is an example of satellite communication. So you have to be in the line of sight, hmm? But because Earth curvature, because of the shape of the Earth, one satellite can cover a very large area on the Earth. If you look at this satellite, it can cover all this area on the Earth, right? Whatever it can see, a very wide area it can cover. Okay, now routing protocols we use for obviously whenever we are looking at the WAN, we always look for the routing, because without routing, WAN is not possible. A wide area network is not possible without routing, because you have different type of networks, different IP addresses, different services, different ports. Everything is, so we have a kind of multiverse of different types of networks, and all wants to communicate with each other. So routing is required for that. So for example, you are sitting here, this is you, and connected to the internet. You can reach anywhere in this world, and that is only possible because of routers. There is a series of routers connected to each other to reach a particular destination. A router to router to router to router, and then finally you reach your destination. If you ever get to know, means if you have ever get this trace route command, if you ever get to use this trace route command, hmm, this trace ERT or trace RT or trace route. If you are using this trace RT or trace route command, if you ever get a chance, because these public websites does not allow to use this trace route command, so you won't get any response from there. For example, if I try to use trace route on Google, it goes to the first hop. These are called hops. Hop, 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 hop. So these are called hops. So it reaches up to the first hop, and then after time down, because it does not allow me to go out. Or maybe even my gateway is blocking my request from going out. So I reached to my gateway, but I cannot go out. Right? So if you ever get a chance to use trace route, there was a time when maybe from home, if you use this command at your home, there maybe you will see all the hops from your system to the google.com. How many hops you need to pass before your request reaches google.com? Okay. Even if I try anything else, because it is blocking my request at the gateway level, I won't be able to get anything here. So routing protocols are must and very important in your wide area network. So when you study more in the Cisco, the Cisco has various types of routing protocols. Okay, now you can see routing protocols. So some of the examples of routing protocols given here: OSPF, EIGRP, RIP, not the one RIP we say. So these are some of the protocols we use. We call them interior gateway protocols, and there are some exterior gateway protocols, EGP. So BGP is one of the exterior gateway protocols we use. Now we configure these protocols on these routers. On these routers, we configure these protocols, and these routers has their own routing table. By manipulating or by controlling these routing table, we can manipulate or control the networks. Like what network can be connected via this router or that router. If I want to block the access of certain networks, I can do these on these routers, whichever router we are controlling. So there are companies, I'm missing that name of the company. There are companies sitting in this or managing all these multiple routers. They are, we can call them companies. Those companies are paid by the bigger companies such as Google's, Microsoft, and all those. So any company who is willing to use the network, they are paying to those companies to manage the internet. Though we say that nobody is managing the internet, nobody owns the internet. Though nobody owns the internet, that's fine. But there is someone who's managing this network. And there are companies, they have their offices in different time zones, like office in America, office in Europe, office somewhere in Asia Pacific. And they are controlling transatlantic, trans-Pacific internet lines, and they manage the traffic flowing through these lines, and they actually know how much data or how much traffic is flowing with those through those lines. I still can't recall the name of one company I know. Okay, types of routers. So core router, edge router, exterior router. So you can read about them from here, and you can see their positioning on the network, right? Where the core, edge, or exterior routers are placed in a network. So whenever you are designing a network, you design with these routers in place. Routing table is very important part of every router. Every computer, remember, every computer has its own routing table. Oh, sorry. This is the routing table of this computer. This is the routing table of this computer. That, what does it mean? It means that this computer has already contacted these computers and get the physical MAC address of those computers. So my computer here at the podium knows all these computers and their MAC addresses. What is the command? Command is ARP-A or -A. If you run this command on your computers, you will find a different result. See, so in order to communicate to these computers, I don't need to get the MAC address first, because I already have the MAC address. So this is my computer's routing table. Similarly, the routers connect to the other routers. This router connects to the other router, so it has the path, or you can say the IP address and the MAC address of the port belongs to this router, and there can be other routers connected to the same router, switch. So one router may be connected to multiple devices, and it is maintaining the IP addresses. Now, this switch is connected to hundreds of computers. Hundreds of computers are there. So does this router knows all the computer IP addresses? The answer is no. This router only knows that what network ID is on this side of the router. Only network ID it knows, not the host IDs. So router only means, for example, this computer, in the computer routing table, what does I see? What do I see? I see the IP addresses and the MAC addresses. I see IP address, MAC address. But your routing table, router's routing table has the network IDs. What network is on the other side of my network? What network is available here? What network is available here? What network? What network? Only network. The router knows about networks. So that is maintained in the routing table. Now every router maintains its own routing table, means we can enable it or we can disable it. We can say that no, router should not learn its own network. Whatever I provide, then only it should learn. So either you can control the routing table manually, or you can let the router learn the network automatically. So if someone is trying to access this computer, so it is going to learn this path. This router is going to learn this path, that someone from here can reach to this computer through this path. Oh yeah, this network exists, or this network is sitting on the other side of my computer or my port. So these are the routing path types. One is static routing. So a network administrator configures the routing table. So that is the manual part. You want to control your routing table. Dynamic routing, router automatically calculates the best path. It is something like you put the GPS to go from one place to other place. So GPS is controlling your route. Or you know the route and you are using your own experience to get the route. So either you are doing it manually, or you are, which one is the most secure, by the way? Static route will be the secure, because that way you can control. Okay guys, I think now I'm not able to speak more. So we stop here, and I will continue from the same slide next week after school break. Okay. I will adjust the dates if required, and I'll make the announcement or send the message to you guys as well. Okay. Thanks for the day. See you. Enjoy your spring break, and see you after.